Okay, take it away, Michael.
All right, awesome. Let me just share my screen really quick. All right, everything look good?
Yep.
Let me just hide the meeting controls. All right, awesome. So what I'm going to be talking about today is creating plots to display weather data using the Holoviz and Geoviews libraries in Python. I did this with Kevin Tile. He's been a really great mentor to me and really helped me a lot through this project. It's been great collaborating with him. He was my professor for a couple classes, teaching me how to use Python. I fell in love with coding, and now I'm here giving this talk. So, all right. So a little bit of background about myself. I am a current senior in the Department of Atmospheric and Environmental Sciences at UAlbany, soon to be graduate student here. I'm very excited for that. I love winter weather. I study atmospheric sciences, and you could see a couple pictures of me. On the left, I was part of a fieldwork campaign that studied mixed precipitation. So that's me and one of my peers over there launching the weather balloon. You could obviously see how happy I am. You can see how happy I am too in the middle picture. I went chasing some lake effect snow off of Lake Ontario in November, one of their big snowstorms that they had. And then on the right, there's me presenting some of the research that I've done at the American Meteorological Society annual meeting in Denver this past year. So really just love all things weather. I love the UAlbany department, and they gave me all these great opportunities. So the motivations behind this project, we really want to create an interactive visualization web application for atmospheric science related data sets, whether that is on the weather side or the climate side. We really just want to bring interactivity into the weather sphere. And then our second big goal is we really want to make use of cloud hosted and with a special emphasis on these analysis ready cloud optimized or ARCO data sets, which are just very efficient to use, very efficient to remotely point to data and then subset and index it. So the goals for this project, we have a few. Making interactive plots, obviously, of ASOS and MPing data. That could be expanded to just point data in general, but ASOS and MPing were my original motivations for this project, and those display real-time weather, whether that be at airports or some citizens report, and I'll get into that in a little bit. Era5 data, which is a reanalysis data set, which is going to be really cool, which is now kind of our main focus on this project. And then in the future, looking at ways to implement numerical weather prediction or model data into this interactive sphere. And then we also, as I stated before, really want to demonstrate the benefit to the community, really to the weather community of using ARCO data sets and hopefully pushing to get more of these data sets in an ARCO format. So the previous work that's been done in a visualization sphere, there are plenty of websites out there that do data visualization. On the left, we have Tropical Tidbits and Pivotal Weather, which kind of display numerical weather prediction or weather model data or some climate data as well. But however, for these websites, most of the visualization is in the form of PNGs. There's not, there's little interactivity on these websites in allowing the users to index data themselves. And that's one thing that we'll get into when looking at ERA5 data. And then for ERA5 data specifically, we really lack an effective means anywhere to select or display huge data sets like ERA5. So yeah, that's really what we want to have an emphasis on is moving away from just these kind of static PNG formats where users could select variables and getting into a more interactive space where users can zoom in and zoom out and really be at the helm of what they want to see and how they want to visualize the data of what works for them. So getting into how we're using Holoviz and ARCO. Holoviz, we're using Holoviz to bring this interactivity that we want to meteorological and climate data. And within Holoviz, they have a couple of subsets called Geoviews and data shaders. So Geoviews it allows us to geo-reference this point data or the gridded data that we'll see in a bit. And then the data shader makes things a little bit smoother when plotting gridded data sets. Of course, we want to use ARCO data sets whenever possible within this project to be able to more efficiently load in and visualize the data that we're using. So that gets us into my original motivation for this project was plotting point data, ASOS and MPing. There really are not a whole lot of places to visualize this type of data. What we see here on a map are the collection of 900 plus automated weather stations across the US, whether that be at the National Weather Service or for the FAA. And in general, this point data tends to get left behind, as I said before, in terms of visualization. Briefly touching on MPing, if you aren't familiar, MPing is an app where citizens can report weather at their location. So you just load in the app. You basically say it uses the location of your phone. So you basically go in there, you say, hey, it's snowing at my location or it's raining at my location or whatnot. And that gets put into a database that can be visualized. This really was the original motivator for this project. I'm really interested in mixed precipitation, and being able to see exactly what's going on where across the country is obviously super important. And there just aren't a whole lot of means for visualizing these types of data sets. So here are some examples using the interactivity that I've explained before. On the left, we see a collection of ASOS and MPing reports reporting precipitation type. So this was about a month ago or so, or a little less than a month ago. You could see a lot of rain reports across the Southeast and some snow reports across the Rocky Mountains. And you're able to interactively look at each of these sites, and it gives you information about the station, the time of observation, what precipitation type, even the temperature. So, and then looking at this area on the bottom right of the screen, we see a front that's set up across southeastern Nebraska, where you're in the 40s, in northwestern Nebraska, and in the 80s in southeastern Nebraska. So we're going to try and do a quick live demo here. Let me just be able to share my screen. How could I get back the controls? Oh, there we go. Awesome. Thank you. All right. So here is, we're able to see that. All right. So here is the what I was talking about in an interactive environment in a Jupyter notebook. So this is that precipitation type map that I was showing before. We could zoom in on the Northeast. And we could also go through time. So this will show you the last 24 hours worth of data, and we could filter and go through different times, which seems to not want to work right at this second. But we are able at, usually when running this notebook, you're able to go through different times and really grab the last 24 hours worth of data. Let me see if it'll let us select, which doesn't seem like it, but usually you'd be able to, this is really the interactive interface that we have working. And in my couple experiences doing this on Zoom, for some reason, it messes a little bit with the Jupyter notebook in terms of interactivity, but we could still go through and select different points like this. We could look at this station specifically in Albany for yesterday at 20Z, so 24 hours ago. The Albany airport was reporting drizzle. And users could come over here and select through all these different types of data sets, whether it be precipitation type, temperature, real field temperature, wind gusts, and reload the map and have those there. But I think Zoom messes with things a little bit for some reason the couple times that we've tried this. So
do you need to just execute the cell again by chance?
We may need to. Let's see if that fixes it. Yeah, I don't know if it wants to. Oh, maybe that did work. Let's see. Oh, yes, here we go. All right, awesome. Yeah, just had to re-execute the cell. Okay. So and you could see, we could go through hour by hour and see how the reports change at different airports and different MPing reports. Yeah, like some of these are MPing reports here. Some are ASOS reports, and we could switch and go to 2 meter temperature, and there we go. And yeah, we'll see briefly. It takes about 10 to 15 seconds, and also for some reason that doesn't want to play nice either. But generally, we're able to switch through and index these different data sets. So let me just hop back to the slides real quick. All right, we see the slides again. Awesome. Okay, so one drawback that we've found when plotting these ASOS and MPing reports in Geoviews was an issue with plotting multiple. If you have multiple gv.point arguments, that kind of, for some reason, makes things a little messy when using different color tables and whatnot. So I opened an issue on the GitHub, number 618. That will be hyperlinked here if you look at the slides. And then on the bottom here, this is the specific issue I opened. So basically what we do is we just mesh MPing and ASOS reports into one data set, but we'd like a way to maybe more easily distinguish what's an ASOS and what's an MPing report. But currently, for some reason, that just seems not totally possible. So now moving on to what we found to be really, really interesting and likely of high interest to the community is ERA5 data. So if you're unfamiliar, ERA5 data is a state-of-the-art weather and climate reanalysis with dates stretching back to 1979. However, some preliminary data does go back to 1950, but the data set we'll be looking at stretches back to 1979. So there are a few different options for ERA5 data. The first one, which is the main storage for this data, is Copernicus. The next one that we'll look at is the NCAR RDA server, which uses Thread and OpenDAT protocol. And then this Google Cloud protocol, which is stored in S3 in ZAR format, which is an ARCO data set. So when we initially tried this, we used this NCAR RDA OpenDAT protocol to select the data. Couple issues with that. It's not totally scalable if many users are accessing the data at once. But the more annoying thing that we ran into with this is that different variables are just very difficult to work with. Depending on the variable you're selecting, some data is accessed with 16 days loaded, some you could only grab 1 day at a time, and some you could grab 1 month at a time. So when you're just using one specific variable, it's not too difficult to work with, but when you're bringing this to an interactive environment and letting users select what variables they want interactively and what dates that they want, it becomes a bit more of a challenge to make that work. And you'll see right here what I'm talking about. So this is in Python. This was opened with Xarray, the different data sets. We see each one of these is a different variable: wind, large scale rain rate, and 2-meter temperature. And we see this data set on the top right, you're able to grab 24 hours worth of data at one time. This one, you could grab 16 days worth of data. And then this one, you are able to grab a whole month. So when trying to work with all those different data sets, it's hard to have code that will efficiently work for all of them when users are selecting different days and whatnot. You can imagine if you need to load in 16 days, but a user wants to load in a day between the 15th and the 17th, you'd now need to load in 2 data sets instead of just 1. So that's when we moved to this Google Cloud Protocol S3 in ZAR format data set, this ARCO data set. A lot of benefits to this. The data is more consistent between variables. So we see there are only 2 different data sets, all stored. You could find 1979 through 2021. So it's not like you're only grabbing certain subsets at one time. All of the data is there and be able to be remotely accessed. On the left here, we have forecast variables, and on the right here, we have the reanalysis variables. So much, much easier to work with. For this particular data set, the data only goes from 1979 to 2021. And I'll talk about that a little bit in the drawbacks, but right now, the data is only available up to 2021. And there's also really good documentation on how to efficiently plot and work with the data on their GitHub page. So going through a few cases, here is December 1989, which was a historic cold outbreak. This, I believe, was St. Louis's lowest temperature ever recorded at, I believe they got close to 20 degrees below zero. So this is one example of using this data. And we see on the left here that users are able to select a variable, a pressure level, which I'll get into, and then different days. The next case that we thought was pretty interesting to look at was Hurricane Sandy. So this looked at mean sea level pressure. We could see this reanalysis was on October 29th, 2012, right before Hurricane Sandy made landfall at 948 millibars. And then another case we looked at here was the storm of the century in 1993. this is looking at precipitation rate. So let's see if we could do a live demo of this. All right, so here's Hurricane Sandy. Maybe we could, oh yes, all right. So here we've selected multiple days worth of data, and we could kind of just go through these and see how Hurricane Sandy, really moved, and see it as it makes landfall across New Jersey, and then a few days afterwards, or a few hours afterwards, excuse me. So yeah, this is really just a super cool way to visualize this type of data. And you're able to select different variables. So let's say we wanted to do temperature or stay at mean sea level pressure. And then let's say we wanted to go to the storm of the century of 1993. So users just can select the date. So the starting date on the 13th, and then automatically it won't let users select, days or weeks or months worth of data. It has to be, a reasonable match. So right now where I have this filtered to where users could only select in between 1 to 3 days worth of data. And then you just click this reload map. And then hopefully by the time we get back, that will be loaded in. And that's one of the drawbacks that I wanted to talk about as I quickly go back to the slides here. Let me just hide the controls again. So some of the drawbacks in terms of working with this data, the data is not currently in latitude and longitude coordinates. It's actually in Gaussian coordinates. And in order to plot this data set in a georeference way, we need to convert to latitude and longitude coordinates. So that takes extra time and resources to get ready to plot in Geoviews. Many of the variables also are not yet available. Only surface variables are available. There's nothing on pressure coordinates. There are some entire atmosphere variables like precipitation rate that I showed before for the storm of the century. And things generally take a long time to plot. Between the regridding and the actual plotting itself generally takes about 2 to 5 minutes for 3 days worth of data. And when scrubbing through, things aren't completely smooth like I showed before. There is a little bit of a time lag between scrubbing through the data and a latency when that data actually appears at that time step that you're on with the slider. So those are just a couple of the issues that we've run into with that. Another challenge that we've seemed to face is with this Google Cloud protocol is on the left here, we see this roadmap. They're through phase 0 and phase 1, as we are able to see with the check marks. But we are not yet in phase 2 where they plan to regrid the data set into latitude longitude coordinates and convert things to pressure levels. And if we look here at the code frequency over time, we see that not much progress has been made on this data set. The last major code additions and deletions were in October and November of 2020. So there hasn't really been a lot of active development, it seems, on this project. That's something that Kevin and I really hope. We hope that development restarts at some point in the future and they're able to kind of get through these phases, but we haven't really been able to, we haven't really seen that in the past 6 months. So if a couple of these problems that I mentioned before could get ironed out, we think it would really be great for the data set in general and visualizing it and whatnot. So some future work, we do plan to make this web application publicly available by leveraging Panel. Panel we've already used Panel a bit in terms of the interactivity when we were selecting data. So where you were able to select variables and the start and end dates of certain things, that was all done through Panel. So we've already have a bit of experience in working with that library, but we really want to make this web application publicly available. We also want to explore more options for efficiently plotting this data and for interactivity. In the future, we want to add some more data sets, such as numerical weather prediction and other variables as they become available in ARCO format. Currently, the only weather model really available in ARCO format is the high resolution rapid refresh. That's something we really hope to promote other data sets, not just numerical weather prediction, but in general in an ARCO format where you could remotely see the data and then load it in. And then lastly, we want to submit a Project Pythia cookbook. just to make sure that the code's out there so that the community can build on it. And you know, people who are interested in this can have an example of you know, kind of where to start off. It looks like our storm of the century case is loaded. This is the last, oh, that's not what I want to do. This is the last thing I have to show, but now after a couple minutes, storm of the century case is loaded. We're once again looking at the mean sea level pressure, and we could go through here and you know, look at how the storm of the century evolved down to 964 millibars at this particular frame, traveling through the Northeast and then up and out. So, you know, it does take a couple minutes to plot, but overall, it's really, I feel, a really unique thing. So that's, I believe that's all I have. Oh no, actually, I do have one more thing. Our GitHub page where a lot of the code is currently stored. So that's the last slide I got. So here's our GitHub. There's the link to the GitHub, and we really welcome community contribution to the GitHub repository or any advice that anybody has. We'd love for some community contribution. Currently, the working code is on my branch. So there's 2 branches, mine and Kevin's, and currently the working code is on my branch, but we expect to get that pushed to main pretty quickly. The branch is named MDDev if you're interested in looking at the code right after this talk ends. So, all right, thank you. That's all I have. So does anybody have any questions?